Hi, I'm Kurt and welcome back to Comp Sci 5. Today's topic is going to be tree traversals, but before we get into that, I want to just go over what a binary search tree is and go over the fact that trees are literally just collections of other trees. And by that I mean every tree can be thought of with a root and a left subtree and a right subtree if you're talking about a binary search tree. And a quality that a binary search tree has is for each node in the tree, the value of the left subtree will be less than the data in the node, and the value in the right subtree will be greater than the value of the node. All right, great. Next, we'll go over tree traversals. Like I said before, today we're doing tree traversals. Now, a preorder traversal will go just like this. If you look at this algorithm up here, you're going to access the root, the data that's held in the root. You can do whatever you want with it. For the purposes of this traversal, we're just going to print it. After that, you need to visit the left subtree and then visit the right subtree. So let's go through an example. So we start off and we access the data item by printing it. So we're going to print the root k. Here's going to be our output for the program. Next, we need to visit the left subtree and the right subtree. And you do this for every single node. So if we go here, now we're in this subtree right there. And as our algorithm says, we access the root by printing it. So we'll go with a D. Great. And then we do the same thing. We visit the left subtree. So now we're over here. And as soon as we're at this A is the root of this subtree. So we print it again. Visit the left subtree. It's null. So we can now visit the right subtree of this. Now we're here. So now we're going to print C. Visit the left, null, right, null. Great. This left subtree is visited. Now we can go to the right subtree of node D. Now we're over here with E, and we are going to, of course, print that. Visit the left subtree is null. Now we go here, visit this one right here, and for this one, this root, null, null. So we're here with a print the G. Super. So now we've done this whole left subtree of node K. Now we can go to the right subtree. So for this subtree, this is the root. Of course, we're going to access it with a print. Then we're going to visit the left subtree, which we are right here, and we're going to access it with a print again. Visit the left subtree, null. So now we can visit the right subtree, also null. Now we visit the left subtree for node S, and now we can go to this subtree right here. We're at X, so of course we're going to print that. And now we visit this subtree over here, and for this one, we'll print it, of course. Visit the left, null, right, null, great. Now we visit the left subtree for node X, and now we can finally go visit the right subtree, which is Z, which of course we're going to print it. Visit the left, null, right, null, and that, my friends, is the preorder traversal of this tree. Next up, inorder traversal, and this one is very similar to preorder, except you're going to visit, for every node in the tree, you're going to visit the left subtree, then you're going to access the data item at the root, then you're going to visit the right subtree. So let's go through an example. So if we start off with our algorithm, for every node in the tree, we need to visit the left subtree first. So for this node, we need to visit the left subtree. We need to do that again, left subtree. Visit the left subtree again, so now this is null. Only then can we access the root data item of the subtree that we were talking about, and now we can print A. And now we go visit the right subtree, here. So now we go left, null, print the root, C. Right, null, awesome. So we visited this left subtree. Now we can finally print the root here for D. Great. And now we go visit the right. So we go, for every node in the tree, we need to visit the left subtree first. So we go visit the left one, which is null. Now we can finally print the root, E. Now we visit the right subtree, G. Visit the left, null, can print the root, G. Visit the right, null, super. Now we've finally visited this left subtree for node K, which was the root. So now we can finally access that by printing it. Now we go visit the right subtree. So now we're on this subtree right here, and we need to visit the left first. So we go to the left, great. Now we go visit the left, null. Now we can finally print the root, P. Null, up here. Now we can print S. Great, now we're going to visit the right subtree. Now we're at X, so we visit the left again, null. Now we can finally print V. Visit the right, null. Now we can print X. Finally, we finish off by finishing the right subtree. We visit the left, null. Now we can access the data item Z. And finish off by visiting the right subtree, null. Great. And that is an in-order traversal. Thing to know, an in-order traversal of a binary search tree will produce the correct order of least to greatest. If the beginning of the alphabet was low and the end was high, this would be a correct representation of that. Last up, we got the post-order tree traversal, and for this one, we're going to visit the left subtree, then the right subtree, and only then access the root data that we're after. And that is for every node in the tree, just like the other ones. Let's go through an example. So, for this node in the tree, we must visit the left subtree first. So we visit the left, we visit the left, we visit the left, null. So now, for here, we have to visit the right subtree. So we visit the right subtree, and then we go visit the left, the right. Only then can we finally access the data item with C. So C will be first. Now we can finally access this data item because we've already visited this left subtree and already visited this right subtree for node A. So we can print A now. Super. So now for node D, we've visited the left subtree, so now we visit the right subtree. So we go over here for this node. And remember, for each node in the tree, you need to follow this algorithm. So we visit the left subtree, which is null. Now we go visit the right subtree. And we must visit the left subtree of this node, the right subtree of this node, which is null as well. And finally, we can access that data right there. Gotta love accessing that data. So we visited the left one of E and the right, so now we can finally get E. Super. Now we visited the left subtree of D, we visited the right subtree of D, so now we can also access D. Great, so now we're back up to here and we visited the left subtree of node K, now we must visit the right subtree. So here we are with S and we must follow our algorithm, so we visit the left. We visit the left, null, we visit the right, null. We visited both these subtrees, so now we can finally access P. We visited the left subtree of node S, let's go visit the right. Now we're at X, we now visit the left subtree of X, V. We visit the left, null. We visit the right, null. We can finally access the data. So now we're up here, we visit the left subtree. We need to visit the right subtree of node X. Here we are with Z. We go visit the left, null, the right, null. We can finally go with Z. Super. Now for this node, we have finished the left subtree. The right subtree, we can access it with X. For node S, we've visited the left subtree and right subtree, so now we can finally print it. Now for the full tree, we visited the left subtree and the right subtree, so now we can finally finish with K. Some things to know, a pre-order traversal, because you pre-order the root, you visit the root first, the root of the entire tree will be in the front. An in-order traversal, since you do the left subtree, then the root, then the right subtree, the root will be in the middle. For the post order, because you visit the left subtree, the right subtree, then access the data, it will be at the end. And that's just a little sanity check when you're doing these types of traversals. Thank you for being with us again. CompSci 5, we out.